How can we label this number using place value? I want you to make sure that you have your math journal or math notebook out in front of you as you're watching this video. If we say this number out loud, this is 79,321 and 45 hundredths. Take a minute and write this decimal into your notebook. You can pause this video at any point if you need more time to write. Think to yourself about the different place values you know from working with whole numbers, but also from working with decimal numbers in class so far this year. Where is the 7? What place value does the 7 fall in when looking at this number? If you said the 10,000s place, you are correct. Make sure that you label the 7 as your 10,000s place, just like the poster hanging in our classroom. What place value is the 9 in? This is our thousands place. There are 9 thousands in this number. Our 3 is in our hundreds place. There are 3 hundreds in this number. There are 2 tens, and there is 1 in the ones place. After a whole number, there's a decimal point. Even when we're not working with decimals, think about money. Whenever there is no extra change after your dollars, we still often see our decimal point, showing that we're working with money and that there could be change or leftovers. Remember that our decimal is representing pieces that are less than 1. The first place value to the right of our decimal point is our tenths place. The second is our hundredths place. Which place value comes next? In your journal, add the number 8. This is the thousands place value. And our word is not popping up. That's okay. Our thousands place comes next. As we move from left to right, the pieces are getting smaller. Think about your green numbers. If you have 1, think $1. 2 tens, $20. 3 300s, $300. As we move from right to left, the size of our numbers grows. As we move from left to right, our numbers get smaller. Anything to the right of our decimal point is going to gradually get smaller and smaller. Think back to fractions. The more we cut apart our whole, the smaller the pieces within it became. Our tenths are our largest pieces in this case, then our hundredths and our thousands. In our notebooks, we have some different grids. This grid is our hundredths grid, and this grid is our thousandths grid. We also have these grids in our binders. Notice how the pieces are smaller, but the grids are about the same size. These are not perfect, but they're close. Let's take a minute and shade both grids. Think to yourself, how could we shade 45 hundredths on this grid? How many tenths are in this number? 4. 4 tenths means I'm shading 4 columns within my hundredths grid. There are 5 hundredths. Our hundredths are smaller than our tenths. To the right, we have another decimal, much like the one we saw on our first slide. This time, though, we have 8 thousandths. Remember from our conversations in class that our thousandths are these tiny little boxes. In every hundredth, there are 10 thousandths. So, if we were to shade here, we still have 4 tenths. not perfect. 5 hundredths. Now we have 8 thousandths. 1, 2, 3, 4, 5, 6, 7, 8. Your place value is easy to take a look at in our grids, and grids can help us see the size of our pieces and understand the meaning of our decimals. In this case, our grid to the right is slightly larger, or our decimal to the right, is slightly larger than our decimal to the left. Understanding place value when working with decimals, whether we're comparing, ordering, or adding, subtracting, multiplying, and dividing, is incredibly important.